given that bromine reacts to form two bromine atoms, and that reaction has an equilibrium constant of 1.1 times 10 to the negative 3, what will be the concentrations after equilibrium is reached if, at this given moment, you have bromine Br2 concentration of 0.063 molar, and right now you have a Br concentration of 0.012 molar. So determine the final concentrations of your two reactants and products, considering the initial concentrations and what the equilibrium constant is. All right. So we're going to see so many problems like this in the upcoming chapters, in which we are given some initial concentrations or pressures of reactants or products, and we're asked to find the final concentrations of reactants or products. We can do this by calculating what the change in the concentrations or pressures will be. And so, being that currently we don't know what that change will be, we only know the relative change of reactant versus product, for example, that we might gain or lose one Br2 and gain or lose two bromines. We'll just be having the values x or sometimes y as our unknown changes in the concentrations. So what you should be doing is calculating or plugging in your initial concentrations, those are given to you most often, into these tables. Then expecting that the change in concentrations and pressures will be negative for the left most often, x if there's a coefficient of 1 in front of this reactant. And then for the products, you want to have a positive value most often, because you need to have an opposite sign for the change in the concentration of reactants versus products. Whereas reactants might lose concentration, products should gain concentration, or vice versa. So these must be opposite signs. So most often you use positive, and then the coefficient from the products in the balanced chemical equation times x here. And so the final concentrations will be the sums of the initial concentrations and the changes. So this final concentration of Br2 is 0.063 minus x. And then for our products Br, we have 0.012 plus 2x. So why do we want the final concentrations? Those actually, I'm sorry. We'll use this later. This is ICE table, equilibrium concentrations. Why do we want the equilibrium concentrations? Because the equilibrium concentrations, their relative values, are described by the equilibrium constant. The equilibrium constant is the concentrations of products over reactants here after they've reached equilibrium, those equilibrium concentrations. And so plugging in for those concentrations, we get the following, which is equal to the equilibrium constant, which was told to be 1.1 times 10 to the negative 3. So now we have just one unknown variable, x. So if we can solve for x, then we should be able to calculate for the equilibrium concentration of Br2 and then also the equilibrium concentration of Br. So rearrange this equation so that we can solve for x. Oh, it's a little bit tricky because simplifying it, we find that we have x squared, x, and then some constant number. You find actually that all that we have here is in the quadratic form. So having this quadratic form of our equation, we need to use the quadratic equation to solve for x. So if we have a quadratic equation, we can solve for x by saying x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So doing that, either using some kind of quadratic calculator on your laptop or your calculator, or actually plugging all this in, or graphing this equation, you can find that the value of x might be two possible values. In this case, negative 0.0105 molar or negative 0.00178 molar. Wow, how can we have a negative change in these values? Actually, that's fine. X can be negative, which would imply, though, that having a negative of a negative would mean that we have actually a positive change in our reaction here, i.e. The reaction is going to the left. So generally, if you have a negative value for x, that means the reaction is going to the left, whereas in most cases, where x is positive, that means the reaction is going to the right. But yes, here we have a negative value for x. But only one of these possible values is actually possible. Okay, so only two of these values provided here are possible. Wow, I'll reword that. One of these two values is possible. How can we know which of these values is possible? You need to plug in for x. And one of the concentrations of your reactants or products will become negative if you have two possible values for x. One of those x values will give a negative concentration, and one will give a positive concentration. And whichever one gives you a positive concentration, that must be the value of x. Whatever gives you a negative concentration, that cannot be the value for x. So taking this concentration of bromine and plugging in these two different values for x, we get that the concentration is either negative 0.009 molar or positive 0.00844 molar. So we know that this negative concentration is impossible. Hence, this x value cannot be the actual x value. However, if we use this value for x, we get a positive concentration. This is the only possible value for x. It gave us a concentration which is greater than 0. And knowing that is the value of x, we can plug that in for finding the concentration of Br2, and we get 0.0648 molar. So we have the concentrations of both our reactants and products, and so we've completed the problem. Thanks for watching, guys.